Welcome. In today's session, I'm going to solve 3 problems in block diagram. So, coming to the 10th quiz, here they have given a block diagram and asked to find a transfer function for this block diagram. So, the solution is here y of s is the output and r of s is the reference input, and let this be the actuating signal E of s and consider the signal feedback signal to be B of s. So you can write y of s as E of s multiplied by 1 by s plus 2, and B of s can be, this is plus symbol and this is minus. So B of s is nothing but, see that the signal flowing here is y of s, output signal. So B of s is nothing but y of s minus the signal flowing here is E of s multiplied by 1 by s plus 2. E of s multiplied by this block diagram is the signal flowing through this arrow. So B of s can be given by, this is the output, these two are the input. So y of s minus E of s into 1 by s plus 2. So from this y of s minus, so this term is nothing but the y of s itself. So y of s minus y of s gives you 0. It is said that the feedback is 0. So no feedback. And we know that if feedback is 0, then E of s is nothing but R of s. So hence y of s is R of s into 1 by s plus 2. So from this, the transfer function is ratio of the Laplace transform of output divided by the Laplace transform of the input. So which is nothing but 1 by s plus 2. Hence the answer is 1 by s plus 2. D is the answer for this problem. Coming to the 11th problem, here they have given a block diagram and again they have asked to find the transfer function, that is y of s. We have to find the ratio of y of s by x of s. So here if you see the blocks, this one and this one are in parallel, so we can just replace this with a block of s plus 1 by s, because these two blocks are in parallel connection. So the simplified block diagram is which gives the output y of s, and this is x of s, and this one is from the branch point here. So you could you could see this as the minor feedback loop. This is a minor feedback loop which is in canonical form. So just replace it. It is a negative feedback. So just apply the formula G by 1 plus GH. Canonical formula. So here you can write 1. Instead of G it is S plus 1 by S divided by 1 plus S plus 1 by S. Here H is 0 because here the H of S is 1. So which is nothing but S square plus 1 divided by S divided by 1 plus S square plus 1 divided by S, which gives you S square plus 1 divided by S square plus S plus 1. So you can write X of S is fed to the S square plus 1 divided by S square plus S plus 1, and the output is again follows a block 1 by S square plus 1, which will give you Y of S. This is minus and this is plus. So from this one you could say that these two these two blocks in cascade connection. So you can multiply this, which will give you the transfer function 1 by S square plus S plus 1, because this term and this term will be cancelled out. So this is the transfer function for this block diagram. So the answer is C1. Coming to the 12th question. Here the block diagram is given. Again they have asked to find the transfer function. So here the output is C of S and input is R of S. So the transfer function is the ratio between the output and input. You can redraw this one like this. G1 is given to the summation comparator. Again G2 it is given to the comparator, and output is C of S. You can redraw this one like this. So I have redrawn the given block diagram like this. This is the same as the given block diagram. So you could say this one is in these G1 and the unity, this branch is unity, just one. So simplify, and these two are in parallel form. So the answer is G1 minus 1. It is G1 minus 1. R of S is the input. You are going to give it to this block, and G2, and it is sent to the summation, and this is minus. And from this diagram you could easily guess that G1 minus 1, this block and this block are in cascade. So the answer is G2 into G1 minus 1, and this one is unity feedback, right? So just this unity feedback unity branch point and this one are in parallel, so -1. So this is the transfer function for the given block diagram. Okay, so the transfer function for the given block diagram is G1 G2 minus G2 minus 1, G1 G2 minus G2 minus 1. So the answer is 1. A option. Thank you.